well, okay, they're not nice derivative rules, guys, but what should be nice about derivative rules?
It should be straight, easy to memorize.
I don't know if they're easy to memorize, but once you have them memorized, you can keep using them over and over again, right? Product rule, quotient rule, power rule, derivatives of e to the u or ln of u. And so just a few of you, I think, are undermining or at least your, wow, the word is not coming. You're not placing the right amount of importance on, there's a word for it. Wow. How important it is to memorize these rules. So just a few of you are, what did I try to say? Underestimating, thank you. You're underestimating the importance of the forevers. Now, guys, there are some forevers that are kind of lengthy and kind of complicated. Like, give me one that's hard. IVT, NVT, EVT, extreme value theorem. There must, actually, we haven't learned that one yet. Never mind, EVT is still coming. Mean value theorem. Nope, we haven't done that one yet either. Dang, you have so much still coming, but that's okay. But IVT, definition of continuous. Is there anything else? It's like a whole big card. Anyway, but these rules are crucial. Just a few of you are settling for, Ready Chapel's speaker yesterday, mediocrity. And it's going to bite you in the butt if it hasn't yet already. Why? If you don't have these memorized, wait. What other classes in your entire school career have required memorization?
Bible.
Everything.
Oh.
Now, what's different about calculus?
You have to apply it.
You have to apply it, and is it just for a test or is it just for a quiz? It's for the entire year. So why do I have forever cards?
Because you need to know it for
You need to know them for the entire year. And so if some of you are like, oh, I kind of know my rules. Now, I love you, and it happens every single year, but if you only kind of know your rules, it's just going to get worse. Now, that doesn't mean that you should beat yourself up. I know. I'm not pointing this at any one person. I'm pointing it at a common problem every single year that I've heard has, like always, hit this class. Not the entire thing, not the entire class, but a lot of you. I'm just warning you. Not memorizing your forevers is like shooting a gun in a snowy pass and just waiting for the avalanche to come. Okay? Like, not memorizing your forevers or settling for, like, I kind of know them, you're just asking for it, and it's just going to get worse. Now, you're going to see a couple of different things today. I don't want to, like, totally set it up right this second, because we do need to get into notes and get into examples, and I want to have that be our first priority today, but you are getting back your chain rule test when you talk about some life. There are some keys to success in calculus. There are some keys to success, and as much as I say it, we need to hear from other students as well, so you're going to get an opportunity to do that also. However, for right now, for today, please hear me that section 2.6a, derivatives of inverses, is a very involved derivative process with a rule, but it's not a simple plug and chug rule. So it does take some extra work, which is why we're trying to develop the idea, the concept, etc. But section 2.6b, even though the rules are going to be nasty, they're still just memorization. Memorizing and learning how to use it. Now, guys, chain rule, was that just memorization?
Yeah. Well, no.
Yeah, why is it not really, even though you do need to memorize chain rule?
Well, because after you get all unraveled, you have to know how to connect like terms and not get rid of stuff you shouldn't.
Okay, so simplifying can be difficult. That's just going to be like a year-long process of making it match and simplifying. Yeah, simplifying can be processed. But guys, is it enough just to memorize the chain rule? No, you have to recognize when to use it, right? Is it enough just to memorize the product rule?
Yep.
No, you have to recognize when to use it. Why do I use boxes and triangles? To try to make your brain always see, it's a product, it's a product, it's a product. What's another one that we might forget? It's a quotient, it's a quotient. So quotient, product, chain, they are memorized, but you also have to recognize when to use it. So please, please, please hear me. If you don't get them memorized, it's kind of like you're sunk before you even start. So to that end, I did give advice yesterday. If you are struggling with your derivative rules, question, how many kids on campus know calculus? Many, because you have 20 BC kids and you have about, 40 that are in AB, a little bit less, 36, something like that.
And you have lots of
There are a lot of kids that are in calculus.
Last
And then last year's ABers, which, I mean, they can still quiz.
remember.
If you know someone who either is in calculus or was in calculus, what's something silly that you could have them do anytime you see each other? What's the derivative of x to the n? What's the derivative of e to the u? What's the derivative of e to the u? Just one derivative rule every time they see you. Why not? Why not? Guess what? We still have some more derivative rules to memorize. And then second semester, we have integration rules. If you don't know the basics, it's kind of stuff. Because you're not even going to get the easy ones right. Or you're not even going to get the easy parts of the hard ones right. Anyway, all that to say, I love you, but you have to memorize. But after you get them all memorized, then what do you have to do?
Apply it.
Apply it. Be able to apply it. And that's where the practice comes in, the homework comes in, the sitting on top of things and asking questions come in, because we have to learn not only what the rules are, but also how to apply. We're going to get back into section 2.6a after Kyle's question. Go.
Well, I'll be, but when you said like second semester's integration, a bad thought came into my brain. I was like, that's what Christmas break is for. Like memorizing the semester preface.
What?
So you said second semester's integration. You don't want to forget. You don't want to not know all the first semester. I was like, that's what Christmas break is for.
Oh yeah.
You can forget.
I already know that one.
Studying.
You guys don't know yet, but I know.
What? Just kidding.
So bad.
Don't worry, it's not that bad. It's not that bad. Ask calculus kids about Christmas break homework. It's not that bad, but it's still necessary. Because I can't have you lose your forever, so I have to make it so bad. Okay, here we go. Let's pray. Jesus, watch over my calculus kiddos. Today might be a rough one for multiple different reasons. Derivatives of inverses are tricky, but so is getting back to changing the test is every year. I pray that you watch over their hearts, their souls, their minds. Lord, may all of our identities be completely solid in you, even when circumstances and our own weaknesses kind of glare at us in the face. Jesus, we weren't meant to be perfect. We were just meant to be obedient and faithful. And the really cool thing is that then you choose to work through us to accomplish really cool things. We each have our own unique gifts and talents and abilities. Lord, grow us. Grow us in the different areas that we are gifted. Grow us in the different areas that we are not. Give us strength and give us grace to be a blessing, but also remind us of how blessed we are today, despite when difficult things come. Praise you that you love each and every one of the kids in front of me, and pray that we can be productive with our time today. In Jesus' name, amen. Okay, so we had this example yesterday, but before we had this example, we did a previous example, and we had a rule. Our rule says, given an original f, hold on. This was a point, right, guys? And from this little statement, I was able to say, cool, who's the point of f inverse? AB. Well, then who's the point of f? What did I do? Just switch it. X's and Y's switch for inverses. That's a pre-cal thing, right? And then we had this rule of we can always find the slope of the inverse at A if we just take the reciprocal of the original slope at B. And why is there that weird he's at A but he's at B? Remember the function that we had in our calculator yesterday? Oh, should I not actually show it? I don't know if it's still in your calculator. You guys have in your calculator right now, don't you have x squared and square root of x, right? And here's the long story short. I can kind of show you on this one, even though it's a little bit weird, because it kind of looks like a squared and a square root, even though it's a cubed root and a cube. If I was to look at the slope of, that's the inverse, of an original. If I was to look at a slope of an original, of an f, the relationship on the inverse to the corresponding point is going to be the reciprocal. It's not the exact same thing. They are going to intersect. They are not parallel lines, even though these ones I happen to choose kind of look like it. I have an f prime of, in this case, we could call this our b. An f prime of b for the point, if I want to say it, for the point b, a. And it's going to correspond on the inverse to 1 over f prime of, that's what my derivative is going to be for this guy, f inverse prime of a. It's going to take that slope and flip it, but this point is flipped. It's a point a, b on the inverse. So every inverse graph has a corresponding point with the original graph, but the x's and y's switch. And so because a derivative is an f prime of x or an f inverse prime of x, since all function notation says give me x's, they must change. The inverse says, oh, my x is a, and the original says, well, my x is b. And so we need to realize there's going to be this, it's going to look like a discrepancy, but it's not. It's the way that the relationship works. And so we have this little, there we go. We have this little rule. To find the derivative of the inverse at a, we can do 1 over f prime of b. And you might be like, why don't we just switch x and y and solve for y? Then we have the inverse, and we just take his derivative. Can I just go straight to the AP test? Because they're going to give you functions that you can't find the inverse of. Either A is impossible to get y by itself, or B, but some of you are like, no big deal, we'll do implicit differentiation. Okay, I get it. Or B, they're going to give you little names of functions like f and g, and they won't even tell you who it is, and you have absolutely no choice because you cannot take the derivative with the rules because you don't know who you are. They literally keep it hidden so that you have to know the rules. I know it's rough, it's mean, but it's the AP. So, coming back, we have to understand how this relationship works between originals and inverses. So with this, we did this example yesterday. Go back, watch the video again. We solved the whole find the derivative of the inverse of sine at 1/2 yesterday. And this was your objective at the beginning of class. Do the same thing to him. So what have we done so far? What did we do so far yesterday? What was this? What was I doing? Well, I did plug in this guy, and I said that he is an x of, I have to figure out who he is in context. Who is he the x of? You guys see how I know that? Because this is f inverse prime of x, right? But yeah, of a. A is in the x spot. Of x of a. So therefore, a is an x of my inverse. And if he's the x of the inverse, that's what I plugged in first. Where else was I able to put him? As a y of the original. But the problem is, in my formula, guys, don't I need 1 over f prime of f's x? So I was missing this spot. This was a big old question mark, and this was a big old question mark. So I didn't have that yesterday. Technically, it was missing. And so what did I do with the 6 in order to try to figure out the 2? Plug it into the original function. Now here's the trick. Is the original function, was it an f or was it an f inverse? What did they give me? Ooh, that's mean. I would much rather plug this into the inverse function. Oh, that's the point. We don't know the inverse function. You can try to switch x and y and solve for y, but some of you would start in that process and be like, oh yeah, no, there's a y cubed and a y, nope, that's okay. There's another way. I'd much rather do the other way. So we're looking for the unknown x to plug in. Maybe we can find it with that, or maybe we need to find it here. We have f. So I'm like, okay, fine. What do I know about this guy? That the y is 6 from this clue. I know that his y is 6. So I plugged it in. Now, Adam, just because I know that you got to some of these last night, others of you might have as well, because you said this on your fingers sometimes. How would you go about solving for x with this expression? But that's not what you got yesterday, right? You're a math student. You've been a math student for years, right? So, as a good math student, what did you think of doing for something similar to this last night? Yeah. He was totally like, oh, I'm trying to actually solve it, because I'm a good math student. We're supposed to get x by itself, right, guys? So maybe we multiply everything by x. So 6x equals x to the 4th minus 4, and then we get everything to maybe one side, because, I mean, we know that factoring is important, or at least we should. Oh, no. But what's the problem now? Is this a quadratic? It's a trinomial, but it's not a quadratic, or else this would be an x to the 4th and an x squared. So sadly, he's a nasty polynomial. From pre-cal, didn't we have like an entire chapter, chapter 2, where we learned how to factor nasty polynomials? No. So you able to make all those little possible zero things and say, well, it could be 1, it could be 2, it could be 4, and then we have to check every single one with synthetic division? No. No, the AP is not going to give you that intensive of a problem in the sense of all the basic math you have to do to solve. There's not time. You get 1.2 minutes per multiple choice. There's no time for that. So here's what we're doing. We're not saying that's illegal to try to factor this polynomial with synthetic division and find the zeros and then break it down. We're not saying that's bad math. We're just saying there has to be a quicker way. And the nice thing is, what I told you yesterday is whether you go here or whether you go down here, if this is an AP problem, which is going to be a multiple choice, even if some of the homework get nasty, if this is an AP problem, it's going to be a nice X. What I mean by a nice X is just start by plugging in. It'll be faster than that whole process. Try 0, try 1, try 2. If that doesn't work, try -1, try -2. Literally, it's faster. Why? Well, 0 minus 4 over 0 is not going to make 6. Forget that. 1 minus 4 over 1, that's -3. It doesn't work. I can just start eliminating, guys. It's going to be a nice do. Literally, all we're doing is, I know it's weird and it's not at all like you've been doing math before. We're doing trial and error. It's kind of like a scientific approach. To be efficient, to be quick, we're just doing trial and error. I don't want you guys to go back to factoring polynomials. You have enough on your plate. So 0 didn't work. 1 didn't work, but what does? 2. Because 8 minus 4 over 2 is 6. And I didn't even have to factor a 4th degree polynomial. Now that's weird though, right? Your brain is going to say, solve! Well, what am I telling you to do? No time. Just start trying stuff. 0, 1, 2. Okay? I know it's weird. If I were you, I would get out a colored pen and I would make a note because your brain's going to forget if you didn't work on this last night, if you didn't already face, I don't know how to solve. You don't have to. Trial and error. I know it's weird. Anyway, we got to 2. How? Trial and error. So we go ahead and we fill in our 2 and say, yay, we found him. Okay, wait, what are we supposed to be doing? To find f inverse prime of 6, we want 1 over f prime of, we found him, 2. F's x. But what was the ... Did anybody keep going? How do you solve? Derive the f. Some of you might want to do that off to the side. Some of you might want to do it in the formula itself. But either way, we need to figure out who f prime is. So f prime of x is equal to 3x squared. Why am I going to do plus 4 over x squared? That would be a CalcChat jump.
What?
It happens every year. CalcChat does these jumps. I don't know why. What do you see?
Well, if you put on the F4.
Can't you rewrite this to be 4x to the -1? So if I was taking a derivative with power rule, couldn't I bring down the -1? A negative times a negative is a positive, and -1 minus 1 is -2. See it? Okay. Once I have my derivative, I have all my pieces. I know my 2, I know my derivative, so plug it in. 1 over f prime. You guys see my f prime being put in the denominator, just like he's supposed to? F prime of who? 2. So get your little 2 and say, I found you. Don't plug in the 6. I need an x, and 6 is a y of the original in context of who I'm looking at. Could we make it pretty? Sure. Could we just try to do the math? Sure, because can't I get pretty quickly with PEMDAS? That's a 4. 4 and 3 makes 12. And 4 over 4 makes 1. What's my final slope? 1 over 13. Now, if I had more time, I would pull up our graphing calculator. I would open the mode, and I would change from function to parametric mode. I would show you a trick that we saw last year. How? Because parametric says, give me x, give me y. You can put in stuff, and then you can switch it for the next one and graph an inverse without ever solving. And I would show you the graph of this guy and the graph of his inverse without ever actually finding him in terms of x, using that parametric cheat trick. And we would be able to look at the 0.62 and look at the 0.26 and see that indeed the slopes are reciprocals of each other. It's pretty cool, actually. But for right now, can you just go on faith that this is a real thing? Can you just go on faith with just this one little baby picture, or the x squared and square root that I gave you yesterday? That an original function and its inverse do have slopes that are related at these corresponding points where x's and y's are switched, and the slope of one is the reciprocal of the other, or the slope of one is the reciprocal of the other. To that end, let me see where my forever card is. Do I have it coming still? Nope. Okay, it's that one which has the formula. Here we go. Let's make this a forever card. I forgot if there was another page in that. Let's make this a forever card. So, let's see. Derivatives of inverse is given an original, and f inverse of a equals b. I'm trying to see if there's any notes that I want to add to this. What card are we up to? Forever number, is this our first one? Yeah, because implicit didn't have a card. So forever number 18. I do want you to write about keeping the points straight, because the clues could change. Here, let's do a quick note. We'll just do this to end it. When finding B. You guys know what I'm talking about? Mm-hmm. When finding B. In the first example, we had to find pi over 6. In the second example, we had to find 2. When finding B, comma, remember trial and error to so anti-Alder math training. Solve for x. No, there's no time. Remember trial and error with nice x values. Guys, I'm not necessarily saying on a forever quiz I'm going to make you memorize that, like actually say, when finding B, remember trial and error with nice x values. However, it is super, super crucial to these problems, and it's something that will get you stuck. And getting stuck is never a good thing, true? Alright, forever number 18. If you guys notice, pretty much the rest of the notes is just examples. Yeah, let's go find another one. Let's skip ahead to, which one do I want to do? Let's do this one.
Oh. Implicit.
Let's do this one. And let me write a little statement at the top. Let's go ahead and say, given. It's not as traditional as I wanted. Let's change it. I don't want you guys to see it unless already written here. Let's go ahead and do y is equal to, I'm going to write it the normal way. Is that okay?
Yeah.
Okay, we were given it in this form. Wait, what's it? The inverse, y. The x's and y's are switched. So then what did I do down here?
Switch it back.
I switched it back, which means I was giving you the original. Okay. They gave it to me written as an inverse. I just rewrote it as the original. Wait, what did I have to do to the point? I had to switch it. So this is my, ready? Keep your point straight. This is my inverse point, and this is my original point. True? Okay, so if I'm trying to find the derivative of the inverse at this point, what am I actually trying to find? Can we at least like state it? I'm trying to find f inverse prime of what?
A.
Who is A? The x of, keep them straight, the x of the inverse, so who's going in here? -4. You see it?
Yes.
There's only one way I could have filled that parenthesis. So f inverse prime of the x of the inverse. Does that make sense? Okay. So what does my formula, the one that we just made a forever card, what does it say that we can do?
And then 1 over f prime.
Got it. Does that make sense what Andrea just said?
Yes.
1 over f prime of the other guy. And the other guy is 1, who's also the f prime of x, the x of the original, right? I know, it's a lot to keep straight. Okay, so how do we actually solve, guys? We don't even need to go looking for b. They gave it to us. They gave us 2 points. We just had to plug it in the right spots. So, what am I missing? We have to do it, right? So I can go ahead and say f prime of x is, let's just take the derivative. He's right there. You got it? 3x squared minus 14x plus 0. Derivative of any constant is 0. So how do I finish this guy off?
1 over.
And what am I plugging into my derivative? 3 times what squared minus 14 times what? 1. Oh, minus 14. I don't want you to make mistakes. And Kyle, what'd you say I'm plugging in?
1.
Got it. Wait, so these problems actually might not be too hard as long as you know what you're doing. 3 minus 14 is negative. So a couple different things. When we had the -4, we needed to look for the 1 to plug into f prime. We had to actually find f prime in order to solve with our formula and then plug it in. But wait, did any of you guys, when you first saw the problem, when I first put it up, did any of you guys think of another way of solving it? Besides just writing it as the OG, as the original, and then using the 1 over f prime of f's x. Did anybody think of another way of solving it when you first saw it on the screen? Implicit. Why not just go for it? So what if we had taken that inverse relationship? Let me just change to a different color. What if we had gone a different way? What if we had taken that x equals y cubed, which was the inverse, and what if we had just gone for it? Like, well, you're the inverse, let's go. But wait, we haven't gotten y by itself. I don't care. Let's just go. We can do implicit. So what would happen if we had taken the derivative? 3y squared times dy dx. Minus 14y times dy dx. Plus, do you guys see how we could have factored out a dy dx? And then we would have had 1 equals dy dx times 3y squared minus 14y. Then what would we have done?
Divided it.
Would we have gotten to the exact same?
Mind's blown.
Wait, what do you mean? No. It would have been wrong because we would have had to plug in the y instead of the. But whose y would we have plugged in?
1 for the inverse.
Same thing. So depending on the clues, if we have a function, we could just take an OG and switch all the x's and y's and do implicit, and guess what we're going to get every single time? 1 over f prime of the y otherwise known as the x. Keep your point straight. Woo! So, technically, if we did have a lot more time to spend on this, we would have talked about how you can use the actual formula or you can use implicit. You can use the f inverse prime of A is equal to 1 over f prime of B. And I would love to say it's totally optional which one you use, but the AP is going to force your hand and make you know this. But if you're given equations like we were just given, there is another way. You could do d dx to the entire implicitly defined inverse, which is what you just saw. We could do d dx to the entire implicitly defined inverse. Either way, you're going to be plugging in the exact same number to the exact same expression. It's just going to look a little differently. This one, you're plugging it in as an x of the original, and the other one, you're plugging it in as a y of the inverse. But either way, it's the same answer. Watch out. Carefully plug in. There is another example, but we're going to skip it for today because it basically does the exact same thing that we just did. So I'm going to save it, change it, move it. Sorry. There he is. So what's due tomorrow? Homework number 13, section 2.6a. But what did I say we needed to start? Section 2.6b. Now, hold on. Where did section 2.6a start? With calculus or pre-calc?
Pre-calc.
Now, I did have you watch the calculus video over the weekend, so you had a little peek as to where the calculus was going. But it started with the pre-calc. Oh, reflections, flipping coins, switching. Because there are a couple times, especially with this whole ABBA thing, that we have to remember some pre-calc. Where do you think section 2.6b is going to start? The pre-calc of? Ooh.
Ew.
The pre-calc of? Okay. Why did I split up section 2.6? Because there were inverses, and then spotlight inverse trick. There were inverses, and then zoom in on inverse trick. So guess where we're going to start? The pre-calc. The pre-calc kind of involves, the SMART program got updated, so some of my spacing's all off. It's supposed to be D:, R:. That's awkward.
That's awkward. That awkward.
Oh no! Can I just do that? Oh, there we go. And then let's just delete all those because ain't nobody got time. If I were you, though, guys, I would get out your phone to take a picture in just a second. Because, yes, we're going to talk about the pre-cal today. But the point is the calculus. The pre-cal is important for like being able to answer sometimes. Kind of like unit circle is important for getting to a final answer, but you have to know the calculus to even know what a derivative is. Oh, that's silly. Why don't I just do this? Aha. Da-da, da-da, and da-da. Okay. Grab out your phones because I am going to show you the calculus. Because there's photo card number 19 coming. I'll see photos everywhere. All right, you guys ready? We're not going to be able to get to the calculus totally today, but I want you to see it. Ooh, pre-cal. Ooh, discovery.
No, stop.
Oh, did I not write them out for you? Okay, here, I'll write them out for you. This one, this page. This is what you want.
Are you remembering inverse rules?
Yeah, we are. Oh, I don't want that. I want this. There we go. Wait to take a picture. Wait to take a picture. Wait to take a picture. Hold on. So you guys see these are just going to be rules, right? Just like those are rules. I'm going to show you an idea behind it. It's going to connect with that whole inverse section 2.6a. At the end of the day, here's what you're going to get. Hey, they're so similar, except this guy has a
Negative because that's the way
the derivative of cosine has a negative sign. No, cosines only have negatives. Oh, but wait a minute. Uh-oh, these aren't of x, these are of u. So what do I need
multiply u
for both of them? Yep, if it's not just an x, I need a u prime. So sine and cosine, the exact same rule, just cosine has a negative. And they both have u primes, so I'm allowing for chain rule. The next one, tangent inverse of u. 1 over 1 plus u squared. Guess what cotangent? Oh, yep, right. Guess what cotangent inverse is going to have?
Negative.
The exact same thing, but a negative. Because tangent and cotangent derivatives are always similar. Now wait, normal tangent is derivative is secant squared. Normal cotangent is derivative is negative cosecant squared. They're similar. They're similar. Uh-oh, you guys gonna get confused? These are separate rules, right?
Yeah.
Put little semicolons. Secant inverse. All right. He's 1 over the absolute value. I know, you can just sigh. It's fine. He's ugly. U squared minus 1.
U?
He's not. Don't destroy his identity. Just his formula's complicated. What do you think cosecant inverse is going to have?
A
The
negative.
exact same thing, but a negative. Does that make sense, guys? So, how many rules are there? Ah, 6. Okay, but really, how many are there?
2.
3. There's the sine cosine one, he has a negative. There's the tangent cotangent one, he has a negative. And there's a secant cosecant one, he has a negative. Has anybody gotten kind of tripped out that these are the derivatives of trig and they have no trig in the answer?
Yeah.
It's because it's not the derivative of the trig. It's the derivative of the trig inverse. And it might not make sense today. Where did all the trig go? Ooh, we can make a song out of that.
Where are you?
We might not know exactly where all the trig went. We might not know exactly where all the sines and cosines and tangents are. Tomorrow we'll get to see where they went. But why am I having you take a picture? Well, tonight, what's your goal? What's your objective? To finish homework 2.6a. But what would it be really nice if you could do? Start 2.6b. And what's the point of 2.6b? The calculus. And where's the calculus? All right here. All right here. Or at least what you need to know. Forever number?
18.
19, right? That's the last one. 18. Okay, so let me get back to the pre-cal pages. Is that okay? Because the pre-cal is important. It might come up in answers or in questions or in ideas. The pre-cal is important. Let me have you guys get it set up. But the key that we're building up to are some rules that we get to memorize. Go team. Are some rules that we get to memorize. Go team. All right, so get the pre-cal all written down, kind of like we did for section 2.6a. We got the pre-cal written down so we could fill it in fast. If you guys want to check in with each other, see how everybody's doing,
How you doing?
now's a good time.
You're good.
Miss D, I got more pumpkin JoJo's yesterday.
What?
I got more pumpkin JoJo's yesterday.
Yeah.
Oh,
Go
so
team.
best.
I went to Trader's on Sunday,
Do you know the one?
and I couldn't decide what cookies I wanted, and I still had a couple at school, so I didn't buy any more yet. I'll do it next month. Huh?
Miss D, do you have coffee creamer in here?
Mm-hmm. Yeah, do it, Abby.
Whoa.
My fridge is just, so that you just come in anytime.
Thank you.
Maybe not anytime.
Do you drink coffee?
I have a Keurig. I had a big enough. We were Keurig, but we forgot. None of us have brought it. Well, because it's not like season. Yeah, but none of us have brought coffee creamers. That's why.
Because today's
I brought
96 degrees.
your latte thingy, but like that, like it was like 4. And Mel had like
Melanie had like 5. No, it was like 8, and she had like 7.
Can we just talk about the trailer last time?
Star Wars. So
Kyle
everything
Stan.
ending, right?
I really texted Kyle because I didn't know who was.
Kyle.
I was like, Kyle.
So, this is my first, not minute.
What are you going here?
The fact that I went to the Mexican movie last year, like,
Yeah, we don't
When did it come out? When
Last
was
December 19th.
no. Oh, which one?
Yeah, the new one.
Oh, yeah.
December 19th.
19. 19 for like the day before.
6 p.m. between 6 and 12.
So this is like that, like a whole Star Wars.
No,
Yeah.
gosh, no.
I mean,
Did
it's
you-
like the
Isn't it?
Skywalker
It's the
saga.
Skywalker saga. They're gonna milk.
They're definitely
Star
gonna
Wars.
make more.
They're gonna milk it.
They're coming out with Kenobi.
They're not coming up with Boba Fett,
Kyle, why do you
Mandalorian.
say milk?
Dude, freaking Boba Fett is like. He was the greatest character in Star Wars.
What
I
happened?
don't know what they're doing
He
today.
was eaten by that.
No, he's not dead.
Boba Fett is.
He's
No,
alive
he's
in Mr.
not.
Strange's
Run out.
room.
Don't fight me on lore. I am
Boba Fett is alive in Mr. Strange's room.
right next to
I
Christian
really love
Holiday.
Mr. Strange.
Next to
He
Mr.
is so he's not funny.
You need to go to- Have you seen it?
I think he got more
Have you seen
comfortable
it
with
yet?
this.
Yeah,
So funny.
it's so creepy. I don't like
He
it.
wears burgers over the weekend. He was telling us how he wants to say it to our diet. Oh my gosh, some of the sauce, I mean, some of the drinks don't have
Yeah.
shit.
And he said it in German.
That sucks, man. Strike is so funny.
Me and Miranda.
Oh.
How close are we?
Almost finished.
Almost done this week.
He always lets Alan do the super shoot or like the worm. So fun. Today's my Snapchat back. Everybody was sleeping and trying. No way. Yeah. I thought I had sent it to Julia. No? It was like second semester. Definitely October 22nd. Where you start.
Do you guys anyone that went to like the thing on Sunday for the Birmingham Con?
No.
I have.
I
On
have.
Instagram.
I went to Stratford.
They were
Yeah,
like
I like
at
it.
my church.
Revival.
Yeah. I'm going to Revival Wednesday.
Oh, I'm gonna get down. I watch this book
Ah.
bro.
Alright, literally,
Oh,
what's
that's
the name? Murph? What's the name of the guy I think from?
More?
Of course.
More? More or more?
That's just it.
I don't know.
He literally calls him more.
I thought it was
Literally
more.
more.
You know how long I've been probably
Why? Because my
half an
eye.
hour or something.
Oh, it's like my personality. Like
Okay.
everything. Personality, that's
It's
bad. That is my Mariah got emoji. I am.
Wait, have you seen that guy?
Let Brian.
Okay,
I know you're
Number
more.
four.
Yeah.
Not really.
Okay, Brian.
Jason keeps Julius.
We all know.
Like, more.
Chicken Alfie said that. They think I'm a koala. I told you. I look like a koala.
Oh,
You know how
Mario looks like more.
Wait, Miss. Oh, I honestly Miss Mary. Miss
Whoa.
Dewey.
Whoa!
Actually, I've gotten that one before. I won't lie.
Miss
Yeah.
Dewey. So when we graduate the school, will our like Google Classroom account be like deleted?
Yeah. I asked Mrs. Packer, and she said it's like within 2 weeks after.
Oh,
Then
cause I
how
was
come
gonna
I
say
can't
I want to
have
be like a
the
40-year-old
ACAS
man and
email?
like be like Google Classroom and open it up and like see these videos
What's
and hear
yours?
all this stuff. And be like,
No, it's
Well, my YouTube channel is
That's
Should
not
I put my
YouTube.
middle name on the
Oh,
diploma?
yeah.
Yes or
Yeah.
no? I hate my middle name.
No.
I hate my middle name.
Kyle.
Forget it.
Okay, guys, in the interest of time, we have about 5 minutes left. I'm really going to try to get through all of the pre-cal stuff today
I love that you know that.
so we can practice the calculus stuff tomorrow, to which end I am not passing back your test today. I was going to. But tomorrow when you come in, grab, your grades are online.
I'm mentally ready.
Tomorrow you can grab a correction paper on your way in. I'm going to pass out the test first thing before we even go over homework questions. And you are going to get a letter from last year's calculus kids to, maybe not specifically you, because we didn't know exactly who all of you are, but to you, trying to give encouragement,
Does it say who it's from?
because, they were all supposed to sign it. Some of them are still here, some of them are not. Some of them are written specifically to juniors, so if you're like, I need help, I'm a junior, maybe you can ask for a junior-specific one. I think I only have 2 or 3. There were a couple that wrote, like Thomas wrote to you, Wyatt, and a few
Aw, that is so
It was really cute. But the rest of you guys, I kind of just randomized it because I don't want to, I don't know, I feel guilty, like,
I
not
want
picking
mine
and
to change
choosing.
out.
But I do scan all of the letters. That's why I can't hand them to you right now. And I put them up in your Google Drive, so if you want to go read over past students' advice, I promise, whatever you are feeling in calculus, whether it is confidence, whether it is complete and utter defeat, or whether it's anywhere in between, there are kids that have gone before you that have felt the same thing. And how they handled it, hopefully as somewhat shown in the letters, which for some of them, they admit it was poorly, and for some of them, they admit it was hard, but they worked and they did really well. You get to hear how they were feeling at the end of the year, because right now, well, you're still kind of towards the beginning. Does that make sense? So, tomorrow you get to come grab a letter. Well, actually, I will give you a letter, and you get to get your chain rule test all at the same time, and we get to talk about how do we do this thing called calculus. But for right now, to finish off today, inverse trig functions, you saw there is a nice, pretty calculus rule page coming. There is a nice, pretty rule page coming that we'll learn how to use, and it's tricky, and it's not always easy. But if you memorize it, it is possible. But there is some pre-cal to go through first, and some of the pre-cal has to do with the graphs. Now, these are all mostly on your basic graphs, right?
Yeah.
So what I'm trying to show you are things like, okay, remember, actually, you know what, negative infinity to infinity, you guys know that just means all real numbers, right? Is that okay? We have all real numbers, we have all real numbers, we have, aren't there some asymptotes that we have to be careful of? Right? We have to be careful of all the pi over 2s. Pi over 2 and then every pi n away from that. You guys don't need to hear me say that though. But these guys, don't they only go between -1 and 1?
Yeah.
They're stuck. They only go so high, they only go so low, but he goes forever high, forever low. So domains and ranges, there's something we have to watch out for. Sine and cosine, forever. But only so high, only so low. Tangent, forever high, forever low, but he has some asymptotes. Now all of these guys have asymptotes too. And they have these weird little restricted ranges where it's like, hey, I can go from negative infinity to -1, and I can go from 1 to infinity, but I have this weird gap in between that I can't because it's bouncing off of the sine and cosine curves. So that's kind of weird, that's kind of funny. But their domains, well, he just can't be at any of the zeros of sine, which happens every pi n. He can't be at any of the zeros of cosine, which are all the pi over 2s plus pi n. And then cotangent, well, he's kind of like tangent but shifted. So he goes forever low, forever high. And his domain, or, well, I just can't be at any of the pi's. There are some patterns. There are some patterns, like cosecant has the same denominator as cotangent. Wait, we saw that with derivatives. They're related.
Whoa.
And secant has the same denominator, aka the same vertical asymptotes as tangent. Oh yeah, secant and tangent are related. Anyway, cool stuff. But we dealt yesterday, at least towards the end of yesterday, with how to take the derivative of an inverse using an original, and we were able to use that weird inverse prime of x, I don't know, weird thing. I'm just going to put b because it gets awkward after a while. I'll put the a. But we're going to see in this section, that's not the only way to take a trig inverse derivative. We can actually take a derivative outright from the trig. We can take it outright from the trig. This was just ratio of sides. Good job, guys. We got pretty much all of the pre-cal.
Yay.
Whew. So tomorrow, we can just have fun with the rules that we're going to learn and use. Sound good?
Yes.
All right. Finish up section 2.6a. If you want your test early, just come on in after school if you want to see it, not in class. Your grade is on RenWeb, but just a heads up, don't worry, our class average was significantly lower, and it is every year. That's why you're getting the letters back tomorrow to be like, oh, it's not just me. Bye, guys.
It's been going down.
This chain rule test is always a very low score.
It's been like going down.
Oh, no. I mean, like, every year, this test is a low score. Does that make sense? Yeah, every year this test is a low. Bye, guys. Love y'all. See you later. No, probably after the weekend.